Okay, so today we are going to discuss on part 6.3 access modifiers and encapsulation. So Java provides 4 levels of access control and all 4 are tested in the OCA exam. Public is the most permissive level. A public member can be accessed from anywhere in the application regardless of package. Okay. Protected allows access within the same package and also from subclasses in other packages, though there are some additional rules for cross-package inheritance. And default access is also called package private. It has no keyword. When you omit an access modifier, the member becomes accessible only within the same package. Classes in other packages, even subclasses, they cannot access it. And private is the most restrictive level. A private member can be accessed only within the class where it was declared, right? So it is not accessible to subclasses or to other classes in the same package. Okay. So here we have two classes A and B, both in the same package com.example. Class A has 4 fields, one at each access level. This example shows exactly what B can and cannot see from inside the same package. Okay. So public means no restrictions at all, right? So any class anywhere can access a public member, and B is in the same package, but even if it were in a complete different package, it could still have access. It could still access pub, right? No issues there. And then protected, right? Accessible in same package. So a.prot is okay, right? So protected means same package or subclass. B is in the same package as A, so prot is accessible. Okay, B doesn't need to extend A to access protected members when they are in the same package. Same package alone is sufficient for protected access. And for default, that is package private. So default access, it has no modifier return at all, means package private. Only classes in the same package can access it. B is in com.example, A is in com.example, same package, right? So def is accessible. From outside the package, default access is completely invisible, more restrictive than protected from a cross-package perspective. And private, it will lead to compile error, right? So a.priv is compile error, means private means the declaring class only. Priv belongs to A and only code inside A's own class body can access it, and B is completely separate class even though it's in the same package. Even though it's right next door, package membership makes no difference for private. Okay, so the boundary is the class, not the package. We have to remember that. So protected access from a subclass in a defined package has nuance that the exam test specifically. When a subclass in a defined package inherits a protected member, it can access that member through its own reference, through these or simply by name. The member has been inherited, so it belongs to the subclass as part of its own state. However, if the subclass creates a reference of the parent type, that is animal A is equal to new animal, then tries to access a.name, that is a compiler error. Okay, so we are going to discuss in detail now. So encapsulation is one of the 4 fundamental principles of object-oriented programming. In an encapsulated class, all fields are declared as private. This means that no external code can directly read or modify those fields. Instead, access to the fields is provided through public getter and setter methods. A getter returns the value of a field, while a setter allows a new value to be assigned. A key advantage of this approach is that the setter method can validate the input before updating the field. This provides an important safeguard. If fields were declared public, any code could modify them freely, potentially assigning invalid or inconsistent values. By using setters, the class maintains control over how its data is modified, okay, and ensuring that certain rules or constraints are enforced. For the OCA exam, a properly encapsulated class typically has all fields declared as private, with public getter and setter methods providing controlled access to the fields. Now, if you see this example, right? So here we have public class bad account, public double balance, right? Balance is public. Any code anywhere in the application can read it, write it, set it to anything at all. Nothing stops someone from writing, say, account balance is equal to minus 100,000 or more, right? No validation, no check, no warning. The object's internal state can be corrupted by any class that has a reference to it. This is the fundamental problem that encapsulation solves. uncontrolled access to internal data. Now what happens, we have another public class account and private double balance private string owner, right? So here both fields are now private, but nothing outside the account class can touch them directly. From any other class, account.balance is a compiler. The data is locked inside the object, but the object still needs to expose its data in a controlled way. That is why getters and setters are there for. Okay, so getters, what do they do is that, say we have this example, right? Public double get balance, return balance. Get balance gives the outside world read access to balance, but only read access. They can see the value but cannot change it through this method. The naming convention, this get followed by the field name with a capital first letter. Okay, and then you see an example of setter, public void deposit double amount. If amount greater than 0, then balance plus equals to amount, right? So instead of a plain setter that just assigns any value, deposit enforces a business rule. You can only deposit a positive amount. Okay, negative amounts and the 0 are silently ignored. The object controls its own state. So no external code can bypass this rule because balance is private, and the way in is through this method only. Okay, this is the key benefit of encapsulation. The validation logic lives in one place inside the class. Every path that modifies balance goes through the same check. You cannot accidentally or maliciously corrupt the balance by bypassing the deposit method. So we have another public string get owner, return owner, and public void set owner, string owner. This dot owner is equal to owner, right? So a straightforward, this is straightforward getter and setter pair for owner. Get owner returns the current owner and set owner replaces it. You could add validation here too. For example, refusing to set a null or empty owner name, but even without validation, the private field plus public accessor pattern, it keeps the design consistent and extensible. So the encapsulation principle in one sentence, if we have to say, we can say that hide the data, expose the behavior, and fields go private, interactions go through public methods that the class controls. Okay, so encapsulation, getter and setter naming convention, right? So Java follows a standard naming convention for getters and setters, and many frameworks and tools depend on this convention. The OCA exam also often tests you whether you can recognize correct and incorrect method names. For non-boolean fields, the getter method is named get field name, where the field name begins with the capital letter. And for boolean fields, the common convention is to use is instead of get. So a field named active typically gets a getter called isActive, while getActive would still compile. Standard Java convention prefers isActive for boolean values. Okay, so setter method always follow the pattern set field name regardless of the field type. So a setter method is usually declared as void and accepts one parameter of the same type of as the field it modifies. Okay, so if you see the example here, public string get name, return name, public int get age, return age. For any non-boolean field, the getter is named get followed by the field name with the first letter capitalized. Okay, and field name is a lowercase, getter is get name, and field age getter is get age. Okay, if you see this example, public boolean is active, return active, this is the naming trap that exam specifically tests. For boolean fields, the convention is not get active, but it is active, like we discussed. The prefix changes from get to is. The method still returns boolean and takes no parameters. So writing get active for a boolean field is not a compiler. It will compile and run, but it violates the Java convention. And setters, if we come here, we see public void set name. Setters are named as set, named set followed by the field name capitalized, like we have discussed. They return void and take one parameter of the field style. Okay, and validated setter, public void set age int age. So if age is greater than equal to 0, this dot age is equal to age, right? So this is encapsulation doing real work. Age cannot be negative in the real world, right? The setter enforces that rule. Only non-negative values are accepted. And set active is straightforward, simple setter for the boolean field, right? So that's about this example. So what happens is that say A and this part, right? Public class A, public int value, and the public int get value, then return value. So here value is public, and anyone can write a dot value is equal to minus 999 directly. No method call is required, no validation possible. The getter exists, but it is pointless. It provides no protection when the field itself is wide open. So having a getter does not make a class encapsulated. Encapsulation requires the field to be private first. Okay, so option A is not encapsulated. Okay, so and then we come to option B. Public class B, private int value, public int get value, return value, public void set value, int v value is equal to v. Value is private, no direct external access. Get value is public, control read access, right? Set value is public, control write access. All three pieces are in place and all at the right access level. This is properly encapsulated, the field is hidden. Okay, so the access is controlled through public methods. So option B is the correct answer. And option C is public class C, private int value, int get value, return value. This one looks close. The value is private, good, but get value has no access modifier. That means default access. So in package, which is package private, only classes in the same package can call get value. From any other package, the getter is completely invisible. Encapsulation means controlled access from outside the class, which implies that getter needs to be publicly accessible, which is not the case here. A package private, getter defeats the purpose, right? And because classes in other packages cannot use it at all. Option C is not properly encapsulated. The getter access level is too restrictive. Okay, so we can see that the answer is option A, fails because the field is public, no protection at the field level. Option C fails because the getter is default, no access from outside the package. And option B succeeds because private field plus public getter and setter is the complete correct pattern. Okay, practice question, right? So what is the question? Question is package com.vehicles, public class vehicle, protected int speed is equal to 100, and then we have another package com.transport. It imports that com.vehicles, then the class vehicle and other stuff like public class bus extends vehicle, void test, system out the println speeds, vehicle v is equal to new vehicle, and system out the println v speed. Okay, so what is the answer, right? What is the result? Result is C, compile error at line B only. Why? Because vehicle is in com.vehicles. It has a protected field speed, and bus is in com.transport, a completely different package, and extends vehicle. So bus is a subclass, just not in the same package. Okay. Now, if you see line A, right, accessing through inheritance. So here what happens is the system out.println speed. Line A, okay, right? But inside bus, speed is accessed directly by the name with no object reference. This is accessing the inherited field, the speed that bus received from vehicle as part of inheritance relationship. So that's what it is, and bus owns this field as part of itself, right? It is bus's own inherited state. So Java allows this. A subclass in a defined package can access protected members through inheritance, through its own inherited copy of the field, and A will compile fine. You could also write this dot speed and it would be identical. This refers to the current bus project, which has speed as an inherited field. However, line B, right, what happens in line B is that we see vehicle v, new vehicle, and system out.println, and then v dot speed, right? So it will lead to compile error. Here we create a separate vehicle object, a completely independent instance, and try to access v dot speed through that reference. This is not inheritance. This is reaching into a defined object, a plain vehicle, and grabbing its protected field from a defined package. Okay, so Java does not allow this. Protected access in a subclass from a defined package is restricted to the subclass's own inherited members. It does not extend to accessing protected members of other instances of the parent class. The distinction the exam is testing is precisely this. Through your own inheritance, it is fine. However, through a parent reference to a defined object is not. Okay, so why this rule exists? This the reasoning is about what protected is designed for, right? Protected says I am sharing this with my subclasses so they can extend my behavior. It does not say I am sharing this with anyone who happens to be a subclass so that they can reach into the arbitrary parent objects. The access is tied to the subclass's identity, not to general access to the parent type. Okay, so result is line A compiles fine, and print 100, line B will lead to compile error. v.speed is not accessible from com.transport through a vehicle reference. Okay, so if you want to practice such questions and get more fundamentals, then you can go to javalan.clustermacro.com. There you have 1624 practice questions. They are 29 full-length practice tests available, and these are timed and fully cloud-native platform. Okay, and you get approximately 100 free questions, and if you get into trial mode, you get another 30 without any credit card. Okay, thanks for your time.